Okay, so all these calculations that we've done, great. We know if we start with a certain number of moles of reactant, how many moles of product we can produce. If we have moles of one reactant, we know how many moles of the other reactant we're going to need, and that's great. But do you know what 18 moles of water looks like? Because I don't. I know what 18 grams looks like, but not moles. Moles isn't something that I have a scale here that can measure. All right, but grams is. So in order for this really to be significant, we need to have things in a unit that makes sense to us, something that we can actually weigh and measure in a lab and things like that. So let's say we have grams of, sticking with our hydrogen and oxygen to make water reaction, let's say we have grams of hydrogen and we want to find grams of water. Okay? We cannot convert directly from grams of hydrogen to grams of water. You cannot. There is no conversion factor that can do it directly from grams of hydrogen to grams of water. Instead, we have to go moles of hydrogen to moles of water. We know how to do that. We've just done it several times. Okay, we just use the mole ratio from the equation. All right, but that still doesn't answer our question. All right, we wanted to go from grams to grams, but like I just said, you can't do that. What you can do is go grams to moles, then moles to moles, then moles to grams. It's a three-step process. All right, you just use three different conversion factors. So for the first step, grams to moles, you're going to use the molar mass of whatever chemical you're converting from. So in this case, it's hydrogen. So you use the molar mass of hydrogen. All right. Second step, easy. You just use the mole ratio between these two chemicals, which in this case, if we look back, it was 2 to 2. All right. Final step, converting from moles of water to grams of water. You use molar mass of water. Okay? Molar mass of water. So this is just a three-step process to get from grams of reactant to grams of product. All right? Now, I'm going to go ahead and show you this, even though you won't need it for tests in my class. But it works the same way for any other unit. I just showed you with grams, but you can do it with molecules too. All right, molecules of hydrogen, and you want to know if you've got so many billions of hydrogen molecules, be a lot more than billions, how many water molecules would be produced by the reaction? Okay, so it's the same process, you just use a different conversion factor. You would use Avogadro's number. Okay, which in this case you'd have the same number of hydrogen molecules as you would water. All right, so you can also do it with volume, let's say liters. Okay, and you would find liters of water. Okay, but for this class, all you need to know how to do is this part. Okay, all you need to know how to do is this part. Grams of reactant, or grams of one chemical, to grams of another chemical within that reaction. And that's going to be three steps. Molar mass to go from grams to moles of your first chemical. Mole ratio to go from your first chemical to whatever chemical you're converting to. And then the molar mass again to go from moles to grams of whatever chemical you're converting to. Alright, I'm going to leave this up here and we're going to try a practice problem. So, let's stick with water here for simplicity's sake. So let's say we have 10.2 grams of hydrogen. Now we want to know how much water, let me write it here, hang on, okay, how much water can be produced if 10.2 grams of hydrogen reacts with excess oxygen. All excess means is that there's plenty of oxygen, so you don't have to worry about the amount. Alright, so let me get rid of this. Okay, so let's go ahead and write our equation. Hydrogen reacts with oxygen to make water. Alright, we'll balance it. So, 10.2 grams of hydrogen. We want to know how much water can be produced. So if we've got 10.2 grams of hydrogen, and our end goal, again, is how much water. So let's look back at our chart up here. So we're starting here, grams of hydrogen. We're ending here, grams of water. We're going to be 3 steps to get there. So I'm going to go through them one by one, slowly for this example. So, first step, we're going to convert grams of hydrogen to moles of hydrogen. Alright? So, grams of hydrogen to moles of hydrogen. We're going to use molar mass to convert it. The molar mass of hydrogen is 2.02, taken from the periodic table. You should be good at that by now. So there are 2.02 grams of hydrogen in 1 mole of hydrogen. Okay? If we did this calculation, it would tell us how many moles of hydrogen we had to begin with. Now the next step would be converting to moles of water. So if we look at our equation, there are 2 moles of hydrogen for every 2 moles of water. That's the same as 1 to 1, so I'm just going to skip that step. 1 mole of hydrogen for every 1 mole of water. So now this would tell us how many moles of water would be produced. So we're almost there. The final step is to convert moles of water to grams of water. Alright, so again we're going to use the molar mass of water this time. So 1 mole of water is equal to 18.02 grams of water. And that is taken from the periodic table. Okay? Cancel out our units there. Okay, to make sure we've done it right, we look at what unit is left. That's grams of water, which is what we wanted. So now we can just do our calculations. So if we do the math, we should get 91.0 grams of water. And that is 3 significant figures because we had 1, 2, 3 up here. Alright, so that's the example right there. We're going to do a few more practice problems and then we'll move on again. Alright, so let's try another one. Let's say hydrochloric acid reacts with barium to form barium, chloride, and hydrogen. So balance the equation and answer. I will type the question for you. So if you have 24.5 grams of hydrochloric acid and excess barium, again, excess just means enough that you don't have to worry about the number, how many grams of each product can you make? So I'm asking you 2 products here. Okay, so remember, balance the equation first. All right, pause the video, unpause it when you're ready for the solutions. All right, I'm going to go through this a little bit quicker to save time. So we've got 24.5 grams of hydrochloric acid, so we know we can start with that. All right, it says each product, so I'll just pick one. Let's do barium chloride first. All right, let's balance the equation. So now we're good there. So we're going to convert to grams of barium chloride. So again, it'll be a 3-step process. Grams to moles to moles to grams. So grams of hydrochloric acid. We're going to convert that to moles of hydrochloric acid first, using the molar mass. So the molar mass of hydrochloric acid is 36.46 grams in 1 mole. All right. Next step, convert that to moles of our product, which is barium chloride. All right. In this reaction, you have 2 moles of HCl for every 1 mole of BaCl2. Okay. And the final step, you're going to multiply by the molar mass of barium chloride, which, give me just a minute to look that up. Okay, it is in 1 mole of barium chloride, you have 208.23 decimal grams. All right, just to make sure we set it up right, we look at what unit we're left with, which is grams of barium chloride, so we know we did it right. Now we can just do our calculation. So if you put that in the calculator, do the math, you get 70.0 grams of barium chloride. So that's how much of our first product we can make. Let's do the same thing for our other one, which would be hydrogen. So again, 24.5 grams of hydrochloric acid. Okay, in 1 mole of hydrochloric acid, you got 36.46 grams. Okay. Mole ratio again is 2 moles of HCl for every 1 mole of hydrogen. Notice how I'm just setting up my conversion factors again in order to cancel them out. Cancel things out like I want. Okay. Final step. In 1 mole of hydrogen, see how that cancels out, you have 2.02 grams. Okay, we got the unit we want left, so we just do the math, and it turns out that this reaction should produce 0.679 grams of hydrogen. Okay, now I want you to notice something about these answers. Okay, so looks like we made a lot more barium chloride than we did hydrogen. A huge amount more, which is interesting because if we look at our mole ratios, right, 1-to-1 ratio, so that's supposed to be the same amount of barium chloride and hydrogen, right? So what happened is we had the same number of moles of barium chloride and hydrogen. The difference is a mole of barium chloride is much, much larger than a mole of hydrogen. Okay, look at the molar mass here. That's 1 mole of barium chloride. That's 1 mole of hydrogen. So those numbers is what accounts for the difference. Okay? I mean, if you look at the whole dimensional analysis process here, those two are the exact same in this case. It's just the molar mass that caused things to be so much different. All right. So that is it for the general stoichiometry practice. There's going to be one more part to this video.